Okay, Assalamualaikum and hi semua. So, sebelum ni video kita dah belajar about SN1 macam mana, SN2 macam mana, and I show you macam the mechanism briefly lah, okay, but general mechanism. Okay, so kita akan start dengan example 1. Kita nak tengok macam mana nak determine SN1 ke SN2, and then kita akan tulis lah mechanism yang related to that reaction. Okay, so let us look at example 1. So example 1 saya bagi kamu haloalkane reacted with OH minus reflux, and then first thing adalah kena determine product lah. So for product kita tahulah Cl ni akan keluar. Okay, so this bond will break, and then OH akan substitute dekat sini lah. So that's why the result is this one. Okay, so nucleophilic substitution je kan. Okay, next thing adalah kita nak identify sama ada this reaction is unimolecular nucleophilic substitution or bimolecular nucleophilic substitution. Okay, so nak determine tu kena tengok class of haloalkane dulu. Okay, so this Cl attached to this carbon. Okay, so this carbon attached to 1, 2, 3 carbon. That means carbon ni adalah tertiary carbon. Okay, so bila Cl halogen tu attach to carbon yang tertiary, that means dia adalah tertiary haloalkane. Right? And then from the table yang saya ada tunjuk dekat kamu hari tu, kalau dia tertiary haloalkane, dia akan jadi SN1. Okay, so kenapa dia SN1? Sebab SN1 kan dia akan form carbocation. Okay, so carbocation, that means di Cl keluar, dia akan jadi carbocation dekat carbon ni, and this carbocation adalah tertiary carbocation, the most stable carbocation. Okay, so that's why they prefer untuk undergo SN1. Okay, kalau SN2 tak boleh, because SN2 dia tak boleh keadaan steric yang tinggi, tak boleh. Okay, macam ni ada banyak alkyl group yang bulky, so dia tak boleh attack carbon yang dekat tengah ni. Okay, so that's why dia adalah SN1. Okay, so ini yang saya cakap tadi. Kalau tertiary haloalkane, SN1 mechanism. Okay, so you can always refer to this table to help you determine SN1 ke SN2. Tapi in exam tak adalah table ni, so kena ingat juga. Okay, so next kamu kena tulislah type of reaction adalah unimolecular nucleophilic substitution ataupun SN1, tapi make sure tulis cara penulisan yang betul, S besar, okay, N capital letter but subscript, and then 1. Okay, alright, so next one kita nak start tulis mechanism. Since kita dah tahu this is mechanism of SN1, there are 2 steps for SN1. The first step is formation of carbocation. Okay, so saya dah tulis dah the starting material over here. Okay, so we know that Cl is a good living group. Okay, so this one dah masuk kali ke berapa saya ulang this thing. Okay, so Cl is a good living group. That means it can easily live on its own lah. Okay, so Cl ni boleh keluar. That means the bond break. Okay, that means we need to push arrow start dari tengah bond. That means we take out these 2 electron in the bond, and then siapa dapat electron? Back to electronegativity lah. Okay, C and Cl, obviously Cl more electronegative, so Cl yang akan dapat electron tu. Okay, so we need to write our product balik, which is CH3, C, CH3, CH3. Okay, so since this carbon tak dapat electron, so this carbon become positively charged. Okay, and then Cl become negatively charged, Cl minus. So plus minus dia neutral lah. Okay, so this is what we call carbocation. Okay, so kita dah berjaya menghasilkan carbocation. Okay, and then whenever we form our carbocation, we need to check the class lah. Okay, class kita apa? Carbon attached to 3 carbon. That means class dia adalah tertiary carbocation. Okay, because untuk SN1 mechanism ada possibility for rearrangement. That's why we need to check the class of carbocation. Okay, so settle step 1. Okay, so next is step 2, nucleophilic attack, which is our last step lah sebenarnya. Sebab apa dia last step? Sebab OH minus here is a strong nucleophile. Okay, so dia nucleophile yang kuat. So memang dia akan ada 2 step ni je lah. Okay, so the next step adalah we can see that from our product, OH yang akan attach to this carbocation yang dekat sini. So maksudnya OH akan masuk ke carbon ni lah. Okay, so now we need to think. Arrow kita dari mana? Dari carbon pergi OH ke? Dari OH pergi carbon. Okay, so hopefully kamu dah clear on this one. Arrow kita mesti start from nucleophilic side, which is kawasan yang kaya elektron. Yang kaya elektron yang negatively charged lah. Okay, so OH pergi ke carbon. Okay, jangan terbalik arrow kamu. Okay. So, our product, kita salin balik CH3, CH3, CH3. Okay, lupa pula nak push arrow. Okay, so arrow kita start from this negative to this carbon. Okay, and then over here, kita dah masuklah OH kita dekat sini. Okay, right. And that's all sebab kita dah dapat balik kita punya produk. Right. Okay, so itu je mekanism dia, tak adalah susah sangat. Okay, cuma kena boleh identify SN1 ke SN2. Okay, nak identify, always start dengan class of haloalkane. Kalau tertiary, memang you don't have to think about benda lain lah. Memang confirm dia SN1. Sebab SN2 dia tak suka keadaan steric effect. Okay, alright, so settle. Okay, so next is example 2. We have this haloalkane reacted with water, reflux. And then we will get this alcohol here. Okay. Right, and then kalau kita tengok class of this haloalkane, okay, carbon bonded to 3 carbon, that means this carbon is tertiary, halogen bonded to carbon yang tertiary, that means this is tertiary haloalkane. Okay, so from what we know, okay, tertiary haloalkane hanya akan undergo SN1 mechanism sahaja, okay. Alright, tapi apa beza dengan atas tadi? Produk tu sama je kan? Okay, so beza dia adalah dekat sini. Okay, so dekat example 1, kita guna OH- as nucleophile, which is a strong nucleophile. But over here, kita guna H2O as nucleophile, which is a weak nucleophile. Okay, tadi saya cakap kalau weak nucleophile, dia dekat step 2 tu dia ada 2 step. Okay, right. So, kita nak tunjuk yang tu lah. Alright, so first kita tulis dulu type of reaction. Okay, so unimolecular nucleophilic substitution SN1. Okay, step 1 kita ada macam biasa, formation of carbocation. Okay, now we have our haloalkane. So we know that Cl is a good leaving group. That means it can leave on its own to form halide ion. Arrow from tengah bond pergi ke Cl sebab Cl lebih electronegative. That means kita akan form carbocation dekat carbon. Okay, and then Cl jadi Cl minus halide ion. Okay, so settle step 1. Okay, so step 2, nucleophilic attack. Okay, so kita ada carbocation kita, tertiary carbocation tadi, and then kita ada water as our nucleophile. So arrow kita dari mana? Dari carbon pergi O ke? Dari O pergi carbon. Okay, so hopefully kamu boleh nampak lah. Saya dah tunjuk dah dekat oksigen tu ada 2 lone pair. Okay, so that's mean arrow kita start from yang kaya elektron, which is from the lone pair and go to carbon lah. Okay, right, memang kena tunjuk dia punya lone pair tu, kamu memang kena tunjuk. Okay, so bila dah macam tu, maksudnya we will use this lone pair here to form a new bond with carbon lah. Okay, so kita kena salin balik kita punya structure. Okay, but now this carbon is bonded to OH2. Okay, so O ni dah bercharge apa? Okay, so O ada 6 valence electron. Tolak dengan, okay, O ada 1, 2, 3, 4, 5 electron around it. So 6 minus 5 is plus 1. So that means this oxygen here, the charge is plus 1. Okay, and then from here, I hope that you can see kenapa kita ada extra step tadi lah. Okay, sebab kita nak OH je, tapi dekat sini OH2 yang bonded to carbon. That means we need to deprotonate one of the hydrogen here. Deprotonate means kita kena remove H plus daripada OH2 tu, so that dia boleh form OH sahaja. Okay, so for deprotonation tu berlaku, kita kena guna another water molecule, then dia akan datang deprotonate this H. Okay, so over here saya dah draw water Okay, dan dalam solution kita tu ada banyak berjuta-juta water molecule. So, janganlah kamu pelik, tadi water dah guna dah. Ada lagi? Yes, ada lagi. Okay. Right, so this water molecule will deprotonate this H. Okay, so arrow from lone pair dekat oksigen ni pergi ke hidrogen tu lah. Okay, so O pergi ke hidrogen. But we just want this hydrogen sahaja. That means this bond between O and H need to break. Okay, kalau bond ni putus, siapa dapat elektron? O ke hydrogen. Okay, kena ingat electronegativity lah. So, O more electronegative. That means when this bond break, O yang akan dapat elektron. So, arrow kita mesti tepat from tengah bond pergi ke O. Okay, right. So, kita dah buat dah arrow kita. Then, we can draw our product lah. So, our product is CH3, C, CH3, CH3. So, over here, OH. Okay, dua lone pair sebab dah dapatkan tadi. Okay, this bond dah jadi lone pair. So, total ada dua lone pair. And then, our side product adalah H3O+. Okay, you can write it like this. Ataupun boleh simplify terus tulis H3O+ pun boleh lah. So, macam ni pun boleh. Right, and then ada Cl- yang memang sentiasa floating around jugalah. Actually Cl- tu dekat, once they form, actually dia akan still floating around. So Cl- tu sebenarnya masih ada. Okay, right, so itulah produk kita. Kita dah berjaya dapat produk yang kita nak. Okay, right, so as you can see, untuk step yang weak nucleophile ni dia panjang sikit lah. So once kamu form your this OH2 ni, kamu kena deprotonate dia menggunakan water molecule juga, and then baru kamu dapat your desired product. Okay, so itu yang maksud saya kalau weak nucleophile ada extra step sikit. Okay, so settle for example